Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at electrodes. In this video, we will look at electrode arrays. These are sets of electrodes that are implanted that can measure signals from within the body. These are electrical signals that are used to measure signals from inside the body. Earlier they used to use insulated clusters of wires, hand fabricated technique. It's expensive method, time consuming method and inconsistent and also skill dependent method. Now there is the advantage of using micro fabrication or microelectronic technology to get identical 2D and 3D arrays. Now first of all, it's a very strong word, identical. Process variations still exist, okay. There are still some variability, Identical means what? Much better than the human handmade arrays. That's what it means. It doesn't mean that it's identical. It means that it is nearly identical. That's what it means. It's approximately identical. It's very similar, but process variations still exist and still continue to be a bottleneck. In this case, there are 2-3 types of these. First is the 1D linear electrode array. In this case, square or circular silver chloride electrodes are placed side by side. So there is one electrode here, one electrode there, and another electrode, and like that. These are 40 microns per side. These will have thin film gold conductors on polyimide or molybdenum substrates. And the probes themselves are 10 mm long and about half mm wide. So, and the thickness is about 125 microns thick. This is used for measuring the transmural potential in the myocardium inside the heart. The critical feature is that because this is made of such material that it is flexible and it is so thin that it is flexible that it minimizes tissue damage, and of course it should not damage the heart tissue. So, it minimizes tissue damage. One application is the measurement inside the myocardium. The other is the 2D array. In this case, for example, you are interested in measuring the electrical activity across the surface of the heart, for example, or the brain activity. So, really small, say 1 centimeter by 1 centimeter squared space, there can be several electrodes that may be placed. Miniature electrodes that are formed on rigid flexible surfaces, and each of them has a separate conductor that is connected to the recording instruments. Challenges are involving the connections themselves. The electrode fabrication is one thing, the lead connections is the other one. The example is the one that is used for epicardial potential mapping that has multi-layer ceramic IC. Then you have amplified arrays. If you add an amplifier right on top of the electrode, for example, they added, for example, Olson and colleagues, they added electrodes for extracellular neuronal recordings in animals. And they used thin film micro fabrication techniques to get high density electrode arrays, many electrodes. So, in 1 centimeter, you essentially have 100 electrodes sometimes even more. The other approach is to use sock electrodes, use really small silver spheres 1 mm diameter that are incorporated into fabric, and each sphere is connected to the recording system via insulated lead wires. The disadvantage is that there can be a very large number of lead wires, because 1 mm thick, many come, they will form a bunch, making them difficult to build and operate, and there can be tangling, there can be many such practical difficulties with that. Then you have 3D electrode arrays. 3D means it is not a 3D object like this phone. It is not a 3D object like this phone, that it has a length, it has a breadth and it has a thickness. Not that kind of 3D, but rather there is an electrode that is grows sharper and sharper as it grows. That is the third dimension. Okay. This uses silicon microfabrication or microelectronic fabrication techniques. This essentially uses comb like arrays with 1.5 mm long insulated tines, right. It is only the tips, these are the tines, it is only the tips that are exposed. This is used in neural signal recording and high density mapping. Relatively more affordable low cost solutions have also been proposed by this. Ribbon cables are used to fabricate electrode arrays quite often. So sometimes these arrays use as many as 400 regularly spaced electrodes. The advantages are essentially affordable and fabricated in a standard laboratory. So relatively consistent, this quite often used for cardiac ECG mapping in small rodents. Some common misconceptions and some things to discuss, some caveats are: more electrodes means always better. Well, this is not true because there is always a trade-off between tissue damage and the sensitivity and the spatial resolution that you are getting. So, there is a trade-off between resolution and tissue damage that you are causing. More electrodes that are pinching into the system, more damage could be caused. So, more electrodes is not always better, it is better in terms of spatial resolution, yes. Arrays are essentially single electrodes that are placed apart, placed on a single substrate, for example. Well, this is also not entirely true, because when I have an array, let us say I have an array and I am sampling in a particular spatial distribution. I have an idea of where the electrodes are located. So, I am doing spatial sampling, and because I am recording through time, I am also doing temporal sampling. So, I can get spatial information that is more informative as to how the signal is progressing, how the signal is getting transmitted. That kind of idea I can get because of this spatial distribution, and the manner I can actually vary the geometry and the distribution of the electrode such that, depending on the application, such that I can get better resolution in some spaces and not that much resolution in other spaces. So, I can actually play with or take advantage of the spatial geometry, spatial sensitivity that I am having, because I am sampling through space also. That is the advantage. So, these are not essentially single electrodes. You cannot actually space single electrodes like that, right. So, that is so these are not single electrodes that are placed on a single substrate, it is more than that. Then the other idea that is commonly wrong is high resolution means better. Well, volume conductor effects still persist. What is this? We will discuss in the next class. The other idea is wireless solves all challenges, or wireless solves all challenges. This is also not true, because there are challenges with bandwidth, communication and other such communication protocols and other such challenges that come specifically with wireless. So, it is not that wireless solves all problems. So, with this we come to the end of this video on electrode arrays. With this we end this lecture. Thank you very much for your attention.